Now we will see about the proofs. What is proof? In mathematics, mathematical proof is an argument we give logically to validate mathematical statements. It means simply we will try to prove the statement logically that it is correct or not. That is proof. To validate or prove a statement, we consider two things: statement and logical operators. Here we will use statement and operators to prove the statement. A statement is either true or false, but cannot be both. It is obvious that a statement can be true or false, but cannot both. And which are the logical operators? And, or, not, if, then, if, and only if. These are all the logical operators we will use. Now, there are mainly 6 types of proofs. Mathematicians use several types of proof depending on the nature of the statement being proven and the tools available. What are these 6 proofs? Proof by cases, proof by contradiction, proof by induction, direct proof, indirect proof, and disproof by counterexample. We will see one by one each proof. First is proof by cases. What it says? It evaluates every case of the statement to conclude its truthiness. We will see one example and you will get an idea of this proof. For every integer x, the integer x into x plus 1 is even. Here for every integer x, that means integer are from 1, 2, 3, 4, 5 or to n. So here if x is even, we can take x is equal to 2k for some number k. So statement x into x plus 1 will be 2k into 2k plus 1. Why? If x is even, we can write x as 2k. Now, if x into x plus 1 is 2k into 2k plus 1, we can see that it is divisible by 2, right? So, we can say that 2k into 2k plus 1 is even. Here, we say in the beginning that evaluate for every case of the statement. So, in our example, if integer x is even, we have proved that x into x plus 1 is even. Now the next case is if integer x is odd, we have to prove that x into x plus 1 is even. If x is odd, we can write x as 2k plus 1, right? So statement will be 2k plus 1 into 2k plus 1 plus 1. So 2k plus 1 into 2k plus 1 into 2k plus 2. Here we can simplify it like this. So we can say that it is also divisible by 2. So it is even. So here for the statement x into x plus 1, in both the cases, for even and for odd, we have proved that x into x plus 1 is even. So this is we have proved. In real life, this type of proof is used in algorithm analysis. Now next proof is proof by contradiction. By word itself, we can understand that we have to take the opposite of the given statement and then that opposite statement we have to prove it wrong. If we prove the opposite of the given statement wrong, by default we will prove the given statement that the given statement is true, right? Let's see one example. Prove that square root 2 is irrational. It is saying that we have to prove that root 2 is irrational. Before we prove root 2 is irrational, we have to understand some concepts. What is rational number? Rational number is in the form of p by q, where q is not equal to 0 and greatest common divisor of pq is 1. That means common factor of p and q should be 1 only, not other than 1. Here we will see example. 1 by 2 is the rational number. Why? Common factors in 1 and 2 is 1. 1 by 5 is rational number. 20 by 7 is also rational number. But pi is not rational number, it is irrational number. Then what is irrational number? Irrational number is the real number that can't be represented in the form of pq. It is the opposite of rational number. Examples of irrational numbers are pi, root 2, root 5, root 3, because it can't be represented in the p by q form. Now let's prove root 2 is irrational. First, as per the given concept of contradiction, we have to assume that root 2 is rational. It is the opposite of the given statement. In the given statement, it is said that root 2 is irrational. Square root 2 is irrational. So in the first step, we have to assume the opposite, root 2 is rational. If root 2 is rational, we can write that root 2 is equal to p by q, where q is not equal to 0 and greatest common divisor of pq is 1. Now in the step 2, we have to square both the side of the first step. So root 2 square is equal to p square divided by q square. If we square the root 2, we will get 2. So 2 is equal to p square divided by q square. Now we can do the cross multiplication, or we can say that we 2 multiply by q square means both the side we have to multiply by q square, or either we can do the cross multiplication. So 2q square is equal to p square multiplied by q square divided by q square. Now we can cancel out the q square p square. So what we will get? 2q square is equal to p square. So we can also write it like this: p square is equal to 2q square. If p square is equal to 2q square, we can say that p square is even number. If p square is even, we can write p as 2k. Wherever we will see that some number is even, we can write that number as 2k. Now we will put the value of p in the above statement. So 2k square equal to 2q square. If 2k the whole square, 4k square is equal to 2q square. Now we will simplify it. 4k square is equal to 2k square. 2k square is equal to q square. So q square is equal to 2k square. Q square is equal to 2k square. That means q square is also even. Now p is even and q is even. So p is divisible by 2 and q is also divisible by 8. That means they both share the common factor 2, which contradicts our first assumption or first step that greatest common divisor of the PQ should be 1. Here we have written as PQ both share a common factor of 2, which directly contradicts our assumption that greatest common divisor of PQ is 1, the opposite of the assumption. So here we had proved that GCD of the PQ is 2, which contradicts our assumption. What was our assumption? GCD of PQ should be 1. So if our assumption that root 2 is rational, which leads to contradiction. That means root 2 is rational. We have assumed that root 2 is rational, which we proved the wrong. So the opposite of the given statement can be true. What is the opposite of the given statement? Root 2 is irrational. So we can drive the conclusion that our assumption that root 2 is rational, that leads to a contradiction. So we can say that root 2 is irrational. This type of proof is used in theoretical computer science to prove impossibility results or limits. Now we will see proof by induction. What is proof by induction? It is a method to prove that statement is true for all the natural numbers. What are all the natural numbers? 1, 2, 3 up to n. In this induction, we have to follow the 3 steps. First step is we have to check for the n is equal to 1. Second step is for n is equal to k, we need to assume that given statement is true. And third step is for n is equal to k plus 1, we need to prove that the given statement is true. Here we have written all the steps. Step 1. Check whether the given statement is true for n is equal to 1. Second step. Assume that the given statement is true for n is equal to k. This assumption is called as induction hypothesis. Second step is called as induction hypothesis. And the third step is we have to prove that the given statement is true for n is equal to k plus 1. If above the mentioned all the conditions are satisfied, then we can conclude like that given statement is true for all the natural numbers. Let's see one example. In example, it is said that prove that 1 plus 2 plus 3 up to n is equal to n into n plus 1 divided by 2 for all n belongs to n. That means all n are natural numbers. What is the first step? For n is equal to 1, we have to prove that LHS is equal to RHS. That means left hand side is equal to right hand side. That means we have to prove 1 plus 3 plus 1 plus 2 plus 3 up to n is equal to n into n plus 1 divided by 2. So we have to put n is equal to 1 in the right hand side. Left hand side we will get 1. Right side 1 into 1 plus 1 divided by 2. 1 into 1 plus 1 divided by 2. That means 1 into 2 divided by 2. We can cancel it out and we will get 1. So first step is prove that for n is equal to 1, both the sides are true. For the step 2, it is called as induction hypothesis. We have to assume that for n is equal to k, it is true. So we need to put n is equal to k in left hand side. So we will get like this 1 plus 2 plus 3 up to k. And in the right side we have to put k into k plus 1 divided by 2. In the step 2 we have to assume that it is true, nothing else. For n is equal to k plus 1, we need to prove LHS equal to RHS. So in the left side, we need to put n is equal to k plus 1. So like this, we can write 1 plus 2 plus 3 up to k plus 1. Left hand side is equal to 1 plus 2 plus 3 plus up to k. But we can write that k for n is equal to k plus 1. So k plus 1. If last term is k plus 1, what can be the previous term? K. So we can write 1 plus 2 plus 3 up to k plus k plus 1. From the second step, we know that this one is k into k plus 1 divided by 2, right? And we can write as it is. From this, we can common k plus 1 and k by 2 plus 1. K plus 1, k plus 2 divided by 2. If we will simplify this, we will get like this. K plus 1 into k plus 2 divided by 2. This is the left hand side we are getting. Now what is the right hand side? Right hand side is n into n plus 1 divided by 2. We have to put n is equal to k plus 1. So k plus 1, k plus 1 plus 1 divided by 2. So k plus 1 into k plus 2 divided by 2. And what we have got as left hand side? This. So we can see that they both are matching. So we can say that LHS is equal to RHS for n is equal to k plus 1. Now the next proof is direct proof. If P then Q. It is simple. We will see one example and you will get understanding of the direct proof. If M is even and N is odd, then their sum is odd. M is even, for example 2. N is odd, for example 3. Then their sum is what we are getting? 5, which is odd. This is what we have to prove. As we previously discussed, if any number is even, we can write it in the multiplication of 2. So here M is even, so we can write M is equal to 2k or 2j or 2a. Whatever we like, we can write like this. If N is odd, we can write 2k plus 1 or 2a plus 1 or 2j plus 1. If you take M is equal to 2k and N is equal to 12 plus 1, because N is odd, we can write sum of M plus N as a 2k plus 2L plus 1. If we common 2k plus L plus 1. If this is the multiple of 2, this is even. If even plus 1, that means odd. It is obvious. If even number is 4, 4 plus 1 is 5. If even number is 6, 6 plus 1 is 7. So M plus 1 is odd. And this is what we need to prove. That if M is even and N is odd, then their sum is odd. Here, if P, then Q. Now let's see one another example. If N is even, then N square is even. As we previously discussed, any number is given as even, then we can write number as in the multiplication of 2. So if we take 2k as n, we need to prove that n square is even. We will square the both this side. 2k square. So n square is equal to 4k square. If we write 2 to 2k square, right, we can write in this. If any number is the multiply by 2, we can say that it is even number. So n square is equal to even. This is what we need to prove. If n is even integer, n square is even. Now we will see indirect proof. In this indirect proof, we can say that we have to prove the statement without proving it directly. There are two types. First is proof by contradiction and second is proof by contrapositive. We had previously seen about proof by contradiction. That is, if P then Q. P tends to Q. We need to assume P is true and Q is false. Then after we need to go further. Here we will see proof by contrapositive. That means to prove if P then Q, we have to prove the opposite of Q. Then we need to prove opposite of P. That means prove negation of Q. That means opposite of Q to prove the opposite of P, negation of P. Now we will see proof by contrapositive. In this, we have to prove the opposite of the Q, then opposite of the P. So if P tends to Q, then we need to prove negation of Q, then negation of P. Let's see one example, then you will get complete understanding of proof by contrapositive. If the statement is given as if n square is even, then n is even. So what can be contrapositive statement? From this, we have to take the opposite of this. What is opposite of this? N is even. What is opposite? N is odd. Now we have to take the opposite of this. N square is even. What is the opposite? N square is odd. So here n is odd, then n square is odd. This is what we have to prove the given statement. So if n is odd, then n square is odd, we need to prove, which is contrapositive statement. If n is odd, what we previously discussed, if any number is odd, we can write it like e1 plus 1. So 2k plus 1. So here n is equal to k plus 1, where k is any integer. Now we will put n is equal to k plus 1 in the n square. So n square is equal to 2k plus 1 the whole square. So 2k square plus 4k plus 1. So 4k square plus 4k plus 1. We can common 2 from 4k square plus 4k. So we will get 2 into 2k square plus 2k. Here 2k square plus 2k is even because it is in multiple of 2. So if we will add 1 in the even number, we will get whole number as odd. So n square is odd, which we need to prove. So if n is odd, we have proved that n square is odd. So the original statement is true. Why? Because the contrapositive of the given statement is true. The original statement is true. So we can write like if n square is even, then n is even. Now last proof, disproof by counter examples. In this, we need to prove the opposite of the proof. So in short, we need to show the given statement wrong. That means opposite of the given statement by finding a single example for when it is not satisfied. So we have to find one single example to along the given statement. What is the general method to find this? First, identify universal statement. Then find one example that violates it. That means that proves the given statement wrong. And then last step, show why it fails. We will see one example and you will get an idea of the disproof by counter example. So here we have given one example. Product of two irrational numbers is irrational. Firstly, what is irrational number? Irrational number means it is in not form of P2. That means irrational numbers are the numbers which we cannot write it in the form of P by P. So we have taken example, one is root 2 and another is also root 2. We need to product these two and prove that product of two irrational number is irrational. But what is we have to prove? The opposite. That means we have to wrong this statement. We need to counter this statement. We do not need to prove this statement. Let's take a is equal to root 2, b is equal to root 2, which is irrational number. What can be product of root 2 into root 2? 2. So 2 is rational or irrational? It is rational because we can write it in the form of p by q, 2 by 1. Right? So the given statement is false. Here what we had said in example, product of two irrational number is irrational. But what we get, what? 2 is rational. So the given statement is false. So this is what we need to prove. Now let's see one another example. All even numbers have even square root. All even number, for example 4, have even square root. Square root of 4 is 2. 2 is even? No. Yes. If for all even numbers, so n is equal to 2, it is also even. What is the square root of 2? It is not even. As root 2 is not even, this breaks the given statement, so the statement is false.